Now, as we approach our level 5 problems, level 5 and level 3 problems would be really, really similar because the level 5 and level 3 would be, if you look in the Punnett square, would be in the first column of the Punnett square. Level 3 problems, let me put that here. Level 3 problems would be the ones where uh, you can rewrite both sides as a power of the same number. The level 4 problems are exponential as well as level 3 problems. Level 4 problems are exponential where you can't rewrite both sides as a power of the same number, so then you have to convert to logs. And then the level 5 problems would be log equations that you can rewrite both sides as log with the same base. And automatically, problem A here, you already have log base 10 on both sides, so you would say therefore the arguments have to be the same. We're not dividing by log, so make no mistake. We are not dividing by log both sides. That would be as ugly as if you had radical x equal, let's say, radical 5. You don't divide by radical, and that's just it's just ugly. You don't do that. Anytime you hear the word of after a word, log of, square root of, sine of, you can't separate those. Log is a function, so you have to take the log of something. All right. So anyway, x equals 3. And over here, same thing. We have the same base. We have a log on both sides, same base. So we would say therefore the argument on the left, which is x, is equal to the argument on the right, which is 5x minus 16. Now, if we subtract x from both sides, that gives us 4x on the right. Adding 16 to both sides gives us 16 on the left. And if we divide both sides by 4, we get x is equal to 4. Now, one thing we haven't talked about yet is how important it is when we are solving a logarithmic equation to check the solutions, because sometimes we get solutions that we call extraneous. They are extra solutions that solve a simpler equation like this one, but don't solve the original equation. And the main thing with logs is you can't take the log. You have to take the log of a positive number. You can't take the log of 0. You can't take the log of a negative number. And if you kind of convert that back to exponents, like if you tried to take the log base 2 of, let's say, 0, and you set that equal to x, then you would be saying 2 to some power is equal to 0, and that's just impossible. You can't raise 2 to a number and get 0. So that's why we can't take the log of 0. Also, you can't raise 2 to a number and get a negative number. So that's why the argument can't be negative and it can't be 0. So just keep that in mind, just a thought. Okay. All right. So anyway, the quickest way to check is just to make sure that whatever you get, 4 in this case, that you can take the log of it. Log base 2 of 4. Well, that would be 2 anyway, so yeah, we're good there. And then if we plug 4 back in for x into this x, we get 5 times 4, 20, minus 16 is 4. And we see log base 2 of 4 equals log base 2 of 4, so check. So we don't have to write it out, but it's something we definitely need to do, is always check our solutions. And I got lazy on the other problem, but if we look here, if we put a 3 in for this x, certainly log of 3 equals log of 3, so check. I like to see the check mark that indicates that it reminds me that I have checked my solution. All right, and sometimes you get more than one solution. So let's take a look at this last example here in level 5. Here we have ln's. That means that we have the same base, so we would say therefore the arguments have to be the same. X minus 3 has to equal 3x minus 7. And if we, again, we're going to do a little bit of work in our head here. So if we subtract x from both sides, then we get 2x on the right. 3x minus 1x is 2x. Rewind, pause and rewind, or pause just to try these on your own. Adding 7 to both sides, we get 7. Negative 3 plus 7 is 4, so we get x is equal to 2. Now, there's a big problem with that, and pause the video and see if you can figure it out. The problem is, if you try to put a 2 in there, then you're going to get ln of, log of 2 minus 3, which is a negative 1. So automatically we can't even put it into the, we're not allowed to substitute 2 for x here. And if you tried to put 2 for x here, you'd get 3 times 2 is 6, and 6 minus 7 is negative 1. So 2, you're not allowed to put 2 into either one. And so we would cross it out, and we would say, since that's the only solution we got when we equated the arguments, we would say therefore no solution. No solution. That is what we call an extraneous value. I don't like to call it an extraneous solution, but sometimes I do. Sometimes that can be misleading. Oh, and it's just an extraneous solution. Yeah, it's an extraneous solution because it's a solution to the simpler equation, but not of the original equation. And if a number is not a solution of the original equation, it is not a solution to the equation. Okay, so I want to make sure that's perfectly clear.